Okay. Hi everyone. Welcome to this third week of course Linear Algebra, Advanced Linear Algebra. So first of all, we will recall what was happened in third week. Okay, and then we'll solve some simple questions. And in the meantime, you are requested to ask your doubts if any you already have or it occurs in that time. Okay. So let, let me write here. So third week was basically linear transformation and ranks ranks of linear transformation, and there was this algebra of linear transformation. Okay, three topics were covered. Let me write here. Third week material. Third week material was topics basically introduction to linear algebra. Sorry, linear transformation. Okay, this was
Not visible.
screen is not visible.
So it is visible.
That is visible.
Visual, sir. Visual.
You can check your internet if it is connected properly. Okay. So it is visible for almost everyone. You can rejoin after leaving this meeting. Okay. Then you might see this. Yeah. Okay. So second was concept of rank, and this third thing that was discussed was algebra of linear transformation. So what was I will recall thoda means little bit. Then we'll solve the questions. Okay. So definition was this: a map T from V to W. V and W are vector spaces. Okay, is called linear transformation, which will I denote by LT. If P of T into V1 plus V2 is equal to T into T V1 plus T V2. This happens for every C in field F and V1 V2 in V. Okay, if this happens for every constant and for every vector V1 V2 of V, then the map T is called linear transformation. This was definition. And what was rank of T? Rank of T. Someone can remind me? Rank of T. Say dimension of RT. What was RT? RT was range space of T. What was range space of T? This was subspace of W, which was basically TV. Okay. Sorry, I should write like this. Yeah. TV was the collection. This collection. Uh, P of V such that V belonging to V. These all elements are in W. So this is subspace of W. It was proved in the class. It was subspace of W. Okay. Hmm. Okay, so this was rank of T, and what was null space of T? Null
Some
space
space
was
of V.
this is collection of all those V such that TV is equal to zero vector of W2. Sorry, W, sorry. Zero vector in W, you understand. Okay. This is subspace of V, and dimension of null space. It is also denoted by null space of T, NT, NT. Okay. Dimension of NT is called nullity of T. Okay. So there was this rank nullity theorem, if you remember, which says theorem
Sum of dimension of nullity, null space and range space.
rank of T plus nullity of T.
Equal to dimension of V.
Correct. Dimension of V. How it was proved? It was proved by taking a basis of null space and then extending to basis of whole of V. Okay, and then whatever vector were attached, extra attached, and their images generates range space of T. That is how we proved this theorem. You might recall this because this is an easy proof which uses base extension theorem. Okay, then then it was defined. Uh, okay, algebra of linear transformation. Before that, there was a small result using this rank nullity theorem, which was uh, column rank of A, matrix A, is equal to row rank of A. Okay, this was as a corollary of theorem. Then it was discussed algebra of linear transformation. How it was given, let's say LVW denotes LVW. This set is defined as set of all linear transformation from V to W. So, given any two linear transformation, let's say T1, T2 in L, sorry, L, V, W, we defined T1 plus T2, which was also a linear transformation, which were defined like this. When we apply on V, this is just T of V1 plus T of, sorry, T1 of V plus T2 of V. Similarly, there was a other definition C into T1, T into T, T into T1. This is also a linear transformation which was defined like this: C T1 applied to V is equal to C into T1 of V. For any V, for every V in V and T in S. Using this definition, it was shown. I think it was an exercise to show that LVW, this collection, is also a vector space. Is a vector space, right? Everyone understood now how LVW is a vector space over same field left. So first of all, whatever I have discussed here, uh, V and W are top assumption is V, W are vector spaces over same field F. Okay, this is top assumption. Okay, so LBW is also a vector space, right? We can check some properties if you wish. Should I check it, or I should leave this?
Sir, it's fine.
It's fine. Okay, good. So LBW is a vector space. It it was given a basis here also. If you understood it is a vector space, there was definition of EPQ, which are all linear transformation. This is a linearly independent set. Li subset of LBW and spans. I should write a is a basis of LBW. What how EPQ was defined? EPQ was linear transformation. First of all, let's fix a basis of V1 and V and W. Fix a basis of V. Let's say we will call them alpha 1, alpha 2, alpha n, maybe. Yeah, okay. And basis of W, let's say beta 1, beta 2, beta m. Then define EPQ, which are linear transformation. When apply to a linear transformation, know, uh, if you know it is defined on a basis, it can be extended to a linear transformation of full vector space, right? Their server discussing like uh, given any basis alpha 1, alpha 2, alpha n of V1, and given any element means uh, n elements of W, you can get a linear transformation, right? Sending alpha I to those particularly maybe xi's, let's say. So you get this kind of EPQ defined on alpha I. What was this? 0 if I is not equal to Q, and beta P if I is equal to Q. This is how EPQ were defined, and it was shown that EPQ is a basis of LBW. So this set is consisting of m into n elements, right? P is varying from P from 1 to m, and where should I write? This is wrong notation, but I'm writing here. Q is varying from 1 to uh, n. Okay. So this is cardinality of this EPQ collection is m into n, where this m is dimension of W into n is dimension of V. Okay. So this was also discussed, and then since we are doing algebra of linear transformation are basically maps. So we have composition. Okay, if you have say T from V to W, and next is T prime, which is W to Z. Let's say Z is also some vector space. Then we can talk about what is composition. Okay, composition is also a linear transformation. This is this fact is also shown. Composition of Composition means there may be different vector spaces, let's say V, W, Z, like three vector spaces, or it may happen that we are talking about linear operators. Linear operators are basically linear transformation from V to V itself. Okay, so composition of linear transformation is again a linear transformation. So when you write like map T composite, sorry, first we operate applying T, then T prime. This is understood as T prime into T. Okay, these two are same. Let's say composition is understood as multiplication. Then this composition also satisfies this property. First of all, identity on V applies to T is equal to, sorry, identity on W, T composed with identity on V. This is first. Second is distribution property, where we use let's say Q T1 plus T2 is equal to UT1 plus UT2. The second is this T1 plus T2. From right, it is also distributive. This is equal to T1U plus T2U. Okay. Third property was this: for every C belonging to F, T into UT is equal to CU T is equal to UPT. So satisfying all these three conditions, LVV, I should write now because I'm talking about only LVV. Okay. V to V linear transformation. Then LVP is a linear algebra. Okay, because underlying set is a vector space, as well as here we have these three axioms. Okay, which is also algebra, means we can multiply elements of them. In general, vector space may we don't have multiplication. After some time, we'll see inner product. Okay, but here we have this composition, which is a multiplication of vectors, means elements of W, elements of LVV is called, because it is vector space, I'm calling them vectors. Okay, here we have multiplication. Okay, so this is all discussed, and last thing was discussed about T inverse. If you have a T when T is bijection, means T is 1 1 and onto T inverse exists. T inverse exists. T inverse is a map from uh, if T is if T is from V to W, T inverse is from W to V. So T inverse exists and T inverse is linear. It was proved in the class. Everyone understood, right? T inverse is linear map. Okay. I suppose everyone understood this. So there was last theorem. 1 minute, let me see. Okay. There was this last, I should say, lemma, which says T was T is non-singular or T is 1 1. Both are same. 1 1. Professor also write it non-singular. If and only if. What was this? Can anyone tell for me? If you don't remember, I'm writing it. kernel of t is equal to just trivial 0. Okay, should I prove this or I should leave this?
Okay, sir.
Okay, I suppose everyone understood this. So let's solve some questions, and you can ask your doubts from linear algebra. Okay, or even if it arises in these questions, which I'm going to solve for you. P R2 to R2 a linear transformation. Which of the following function is R linear transformation? Okay. What about this? A, A fails, right?
A fills.
How? Let's say we are checking at some point. Which point we want to verify? P of 2, comma 0 plus. I'm just letting some points 1 plus 1 comma 1. Apply to this. What will get? T of 3 comma 1, which is equal to 9 comma 1, right? Now we'll apply at T of 2 0 plus T of 1 1. We should get this. If we are not getting, then of course this is not a linear transformation, right? So this should be, this is, first one is 4 comma 0, right? Because first coordinate is getting a square and second is same. Now here we
One
get 1
comma
1 only, and this is equal to 5 comma 1, and these two are not equal. So A fails. For B, let's see. B is, we are adding 3 in first coordinate and first coordinate. So T has a property. T has property that T of 0 is equal to 0, right? What will happen here? T of 0 comma 0 will be equal to 3 comma 0, which is not equal to 0 comma 0. I'm talking about 0 vector here. So, so B also fails to satisfy that. See, okay, it seems it should be true. Okay, let's see. T of C into, let's say, x1 x2 plus y1 y2. Okay, so what this be? This will be T of C x1 plus y1 comma. Oh, sorry, I should write comma here. C x2 plus y2. Am I correct? And it will be C x1 plus y1 minus C x2 minus y2. And second coordinate is getting 0. This is first coordinate minus second coordinate. This is what C part is saying, right? Here. Okay. So now we can check C T x1 x2 plus T of y1 y2. Everywhere, if I left comma, then there is comma. You should you understand it. Okay, what is this? C into T x1 x2 means x1 minus x2 comma 0 plus y1 y2 will go to y1 minus y2 comma 0. Now this addition will be cx1 minus cx2 plus y1 minus y2 comma 0, and these two are equal, right? Right, y2 is minus, y2 here also minus, cx2 minus, cx2 minus, right? So C is true. T is a linear, means this T is linear transformation. Last one is D, which is saying apply cos to first coordinate and do nothing with B. So D also fails because when you see A, B plus C comma D, it is going to equal to A plus C comma B plus D, and here it will be cos A plus C. Second coordinate will be B plus D only. And if you apply piecewise, means like this, D, D comma D, this will be equal to cos A plus cos C B plus D. Second coordinate is equal, but there is problem in first coordinate. This might fail for some AC. Okay, you can get some particular values if you wish. What to take? Let's say we are taking A is equal to pi by 4, C is equal to pi by 4. Then this value will be root 2, and this value will be 0. Correct? Everyone understood na this one?
Yes, sir.
Okay, so D fails. Okay, let's see second question. We are taking field to be C. C function defined like this. Okay, but which of the following statement is correct? P is not a linear transformation. Okay, let me ask who is saying this is a not a linear transformation? Let me see. It is linear transformation or no? Just by looking at it, can you say this is a linear transformation?
No, sir.
Okay, but I can say this is a linear transformation. Why? Because because all the coordinates are just linear combination of ABC. Means they got no higher power. Means they are getting just one power. Linear means just one power polynomial.
So
So these are
basically, if it's a square or
That means monic polynomial.
if it's a polynomial, then it's not a linear transformation.
no. I'm just saying ki ABC are getting just single power one.
Yes. So if
So
it's a
A
square or
should be
cube,
one.
then it won't be.
see, in the first question, we see a number. Why a fails? Because there is a power two element. Means first coordinate is getting a square. Okay. Why B fails? Because we this is not completely in power one. Because three a plus three is polynomial which is having coefficients. Sorry, 0 degree term. A plus 3 has 0 degree term. 3 is 0 degree element. Why C is linear transformation? Because 0 is another exception for this for me to understand. But A minus B is a completely in one power. It has only one power terms. So and why D fails? Because this cos, which is This is not a polynomial of degree 1. Cos A, this is trigonometric function, so it fails. So here all these coordinates are completely in 1 degree term in variable ABC. This is why it is a linear transformation. You can prove this, uh, but this is how I understand, because all the coordinates are in um, completely 1 degree polynomial. They can be zero. They can be zero or completely in 1 degree terms. So if here it was just 2, not C, then it fails. Okay. So I'm not going to check it, but the idea which I'm getting, if it is C, let's say, but here it is, let's say, C square. Okay. Then it fails because it is not completely in 1 degree. Understand ABC as a variable, then all the coordinates should be polynomial. Either they are zero or completely in 1 degree term. Okay. Okay. So this is a linear transformation. You can verify it for random coefficients. Put here, let's say, coefficient C1, here C2, here C3. Random coefficients you put once, take it. So the thing I'm telling you will verify. Means you will never forget what is linear transformation. Okay. Okay. See, rank of T is, because of this not, this option is incorrect. Rank of T is 1. How to see rank of T is 1? Okay. So where E1 goes?
We need to row reduce echelon form.
Okay. Someone
We
said
need to
rotative cyclone form, but let's see what I can do. Minus A minus 2B plus 2C. This is your T of ABC. What is happening here? If you see carefully, in the first coordinate, if you subtract second coordinate, you will get third coordinate. Is this right?
yes, sir.
Okay. So once you understand this, and then message in the range space is of this form, it should satisfy this. This option is correct. And what about rank? If you vary A, B, C arbitrary, so these two will be free, but third coordinate is depending on first two, right? This and this. So third coordinate is depending on first two coordinates. Okay, this might not be the way to solve question, but to understand them better, this is the way I think. Okay, third coordinate is depending on first two. So first two are free. So uh, I can directly say rank of E is equal to 2, because varying A, B, C in your field, which is C here, the complex numbers, uh, first and second coordinate. Third depend on first and second.
So if we remove the row reduced echelon form, even then the rank comes 2.
Yes. So this way I see. If you see some question, okay. So
Yes, sir. This is tricky. This is
this is
easy. This is tricky. So it is good for competitive exam.
maybe, but if you get it easily, then why not? You should try this. Otherwise, row reduced echelon form is a good way to solve it. Okay. How to solve? What will be the matrix of T? 1, -1, 2, sorry, 2, 1, 0, -1.
We can find rank of any matrix if we find out the free variables. Number of free variables is the rank of the matrix.
Correct. So here it is this matrix, and if you see uh, R3 replaced with R1 minus R2. Sorry, what? R3 is basically equal to R1 minus R2. So this row is getting 0 if you go by saying R3 min replaced with R3 minus R1 minus R2, not this one, but there it will be 1 minus 1, 2, 2, 1, 0, 0, 0, 0. So once more, if you do this row reduced echelon form, it will be 1 minus 1, 2. Here it will become 0. Here some constant. I'm not writing it. C1, C2, 0, 0, 0. But it two non-zero rows, right? Two non-zero rows. So they will span range space, which is called rank of matrix A. Column rank, row rank, these are all equal, so nothing to worry about. So rank is 2. So this fills. These also filling. So use rank nullity. So
Should be 1.
T fills. I'm saying use rank nullity. Nullity should be 1 because rank should be 2. So this is also done. Okay, 1 minute. I'm writing this matrix for T. Okay, this will be discussed in the next week, fourth week. Matrix representation of T will be discussed in fourth week. But I'm writing here. I suppose you understand them. For time being, you will see in the next week. Videos are already uploaded, I think. Okay. Question 3. Let T and U be linear transformation on R2. First one is defined like this. It's a linear operator because R2 to R2, this map is from R2 to R2. And it is linear because first coordinate is 0, which is possible, and second coordinate is degree 1 polynomial, right, in AB. So here also it is also linear transformation. Good. A and B non-zero elements, so which is incorrect. Okay, let's say we want to like UT. Okay, here everywhere it is written A comma B here because one side it is linear transformation, other side it is vector of R2. Both are not equal. Once you evaluate as AB, then only they are equal. So UT of A comma B, it will be first apply T of AB. What it will be? 0 comma A. What U does? U replaces first and second coordinate you exchange what a comma 0. So 0 becomes second coordinate and a becomes first coordinate. So this is correct. This is what we are getting. Now we should check tu applied to a comma b. So first apply u. So you exchange the coordinates, position of the coordinates. So it will become b comma a. Now what t does? T sends first coordinate to second coordinate, means b should come here, and first coordinate becoming 0. Here it is defined like this. Okay. So is this correct? Yes, it is also correct. U square equal to AB. See, U square of AB is equal to U, 2U of AB. First apply first U, then it will become BA. Now second U, it will become AB. Because U just changes the position of the coordinates. First become second, second become first. So what is T? This is also correct. So this should be the correct option. Because this is only incorrect. And we want incorrect option, right? Okay, let's see if it is true. T square applied to A comma B. What we should get is first applied T, second, so T of it will become 0 comma A, right? And next it should become first coordinate goes to second coordinate. Here it should be 0. Here already it is defined like this. So it should we should get 0 comma 0. But this is saying B comma 0. This is incorrect. Okay, everyone understood? Then I can go to next question.
Please explain D, option D one more.
Okay. So I'm saying D is incorrect. Why? T square applied to A comma B is T of AB. Again, we should apply one more T. Okay, so first the T applies. This AB goes to 0 comma A. Okay. Now next time if you apply T, so what T does? T is defined like first coordinate goes to second coordinate, and in the first coordinate we have empty place. Here it is 0, 0. So once more if you apply T here, what will happen? This 0 goes to second coordinate, this, and you have empty place in first coordinate. Here it is also 0.
Yes, sir. Yeah, okay. Understood.
Okay. So I'm going to next question. I suppose everyone understood. Okay. T be a linear operator on R3. Okay. Now this T, which is also a linear transformation, which I can say directly, and if you can check it. Okay. Any map, any T which is of this form x1 xn is equal to C11 x1 plus C1n xn, comma Cn1 x1 plus Cnn xn. I'm just saying these are all 1-degree polynomials. Ci's are some constant. This is linear transformation. Okay, you can check it. This is a linear transformation. So that is why I'm just telling this is a directly. You can check it. It is a linear transformation. Okay. All time they are talking about I minus t. Let's say we want to calculate what is I minus t. Apply on x1, x2, x3. So this will be I of x1, x2, x3 minus t of x1, x2, x3. So this is identity map. So this will be x1, x2, x3 only. What will happen here? First coordinate is becoming x1 plus x2. Second, x2 plus x3. Third, x3 plus x1. Okay. So subtract it. First coordinate will become minus x2, right? Second coordinate will become minus x3. Third coordinate will become minus x1. This is just minus one of x2, 3, x1, right? Now they want to calculate cube. Everywhere it is asking about cube. So we should apply this operator 3 times on the same vector. Okay. Let's say first time I'm saying t1, second time applying t2, third time t3. All these ti's are equal to I minus t. Okay. So applying to x1 minus x1, x2, x3, it will become first application t3, t2. It will become minus 1 of x2, x3, x1, right? So this minus 1 comes out because linear transformation में constants come
Coefficient should
outside,
be
right? So now apply t2. t3 is here. Apply t2 inside. t2 is again doing same thing. First coordinate is going to third coordinate. Means this is like cycle. Let me draw here. 2 x2. Sorry, what am I? X2, x1, x3, like this. Position are changed, right? Not this way. Huh? x3 is replaces position of x1. On the other hand, sorry, this is wrong diagram. x1 is going to in the position of x3, right? First coordinate after application, it is going to third coordinate. x3 is going into second position, means position of x2. Right. This is incorrect. This is correct. Okay, so t2 is again same operator, so you will get minus 1 here, and x2 will be getting position of x1, so it will be x3 to sorry x1, here x2. This is crucial step I should. If you do not understand, you can ask me what is happening. This should go to third position. This should come to second position. This should be second. This is what happening here. If you see that x1 is going to x3, it is becoming x1 here. Here x3, here x2, and minus 1 is coming, right? So I suppose you understand this. किसी को डाउट है तो मैं बोल सकता हूँ, वरना आगे बढ़ूं.
No doubt, sir.
No doubt. Good. So it is equal to minus 1 of square. Now apply t3 on x3, x1, x2. This time you get minus, one more minus will come. Here it is minus 3. And again, this, it is becoming x1, x2, x3. This is equal to minus 1. And it is It is just identity of x1, x2. Means I minus I of x1, x2, x3. So we see this. Here we had I minus t cube applied to x1, x2, x3. And we are getting minus I of this for every x1, x2, x3 in f3. So this implies I minus t cube is equal to minus I. Okay. So C is correct option. This failed. This also failed. It also fails. You can check it. Okay. Because one side you apply I, first coordinate is again x1 only. And if you apply this thing, because of I is all the coordinates are plus in plus here. Once again, if you apply I plus t, so this will be some polynomial of higher degree. Yes. Yeah, it will be 1 degree polynomial, but there will be x1, x2, x3, all these things, composition of all this in the first quadrant. This is incorrect. So D also fails. I'm not explaining it. Well, okay, let's say question 5. V be the space of polynomials of degree less than or equal to 2 over the field F. W be subspace of 3 tuple. P1 is 1x x square basis of V. P2 is the basis of F3. W is just F3. Sorry. E be the linear transformation defined by this. This is not linear transformation. It should be defined on a basis, right? Okay, this is defined on basis. 1 goes to 1 0 0, x goes to 0 1 0, x square goes to 0 0 1. So what is rank of t? What is the span of these vectors? These are all E of EIs, right? Means these are all in RT.
Rank 3.
3.
So rank of t is equal to 3. Good. Okay. This was not asked in question, but I must. For any P, yes, PP is defined like this. Which are correct? There may be more option to be correct. Maybe. Okay. So for any PX, what is P of PX? P of PX. This will be any P is looking like this, then P is P0 plus P1x plus P2 x square. Because T is linear, so it can be written like this, right? Constants comes outside. P1 of Px plus P2 of P2 into T of x square. But what is T1? It is just E1, 1 0 0. So multiplying P0, it will become P0 0 0. It is 0 1 0 Tx. So multiplying by P1, it will become 0 P1 0. Similarly, this is 0 0 P2. After addition, it will become P0 P1 P2. So this is incorrect option. They are asking about correct. What about P inverse of ABC? Now you see any polynomial which is of this form P naught P1x plus P2x square. This goes to P0 P1 P2. So what should be inverse? This if this is T, what you possibly define the inverse will look like. If ABC is here, you want to take this polynomial A plus BX plus CX square, right? Because once you apply again T on this, you will get ABC. So this is correct choice of T inverse. So this is correct. Now there this is about V. What about V? Dimension of LBW we just saw, means also in the class we see this dimension of V into dimension of W, right? What is dimension of V? It was polynomials of degree less than or equal to 2. It is
3.
3. Dimension of W is 3 because it is W is nothing but F3. Okay. So it is 9. So C is also correct option. But D fails. Just so 9 is the dimension of LBW. Okay. So 2 options are correct. So we are going to next question. Question number 6. Be linear operator on R3 defined by this. This is linear operator. We just every polynomial in x1, x2, x3 are in degree 1. Then the inverse of T is. So if you have T applied already on, let's say, x1, x2, x3, now you apply U on this, it should become only x1, x2, x3. Okay, first of all, let's see if T is invertible. Uh, 1 0 0 goes to 1 0 1, right? 0 1 0 goes to 1 1 0. 0 0 1 goes to 0 1 1. All these three will span range of T. Are these vectors linearly independent? If they are linearly independent, they will span a whole of S3, hence R3. R3, na? Yeah, R3. Let's see if these three vectors, which are images of EIs, are linearly independent or not. So let's C1 1 0 1 plus C2 1 1 0 plus C3 0 1 1 is equal to 0. We want all Ci to be 0. Here it will be C1 plus C2, comma C2 plus C3, comma C1 plus C3. This is equal to 0 0 0. Now this implies C1 plus C2 is equal to 0, C2 plus C3 is equal to 0. Similarly, C1 plus C3 is equal to 0. Now add all these three equations, you will get 2 into C1 plus C2 plus C3 is equal to 0, right? This equation will imply this. Now this will imply C1 plus C2 plus C3 is equal to 0. This is, let's say, fourth equation. Here you have three equations, 1, 2, 3. So now you understand, right? First equation and fourth equation will imply C1 is equal, sorry, C3 is equal to 0. Similarly, C2 is equal to 0. Similarly, C1 is equal to 0. So these are linearly independent. So image of T means rank of T is 3. Means T is, so nullity of T is equal to 0. Means kernel of T is 0. So T is 1 1. There is theorem, it's not here, but a theorem which says if V and W are finite dimensional, then dimension of V is equal to dimension of W. Okay, not then here. And T is 1 1 from V to W. So if and only if T is onto. So this map is 1 1 and onto all because rank is 3 and R3 to R3. It is 1 1 also and onto also it is invertible. So T inverse does not exist. This fails because T inverse exists. We just check. So inverse exists and it is unique. Only one option is correct. So let's see which option is correct. Apply first option. Okay. Hmm. I'm just checking in short here. 2 of x1 plus x2. Just apply T and U remains like this only. X2 plus x3, comma x3 plus x1. We want first coordinate to be x1. Let's see if it is. Now what U does, it adds first coordinate and second coordinate and divides by 2. So here it will become x1 plus x2 plus x2 plus x3 by 2. But this is not x1, right? This is not x1. This is x1 plus x3 by 2 plus x2, which is not, this is fail. This fails. Let's see second B option. B and C are equal. No. In C we are dividing by 3. Okay. So let's say we are checking B option. 2t x1 2 x3. 2 of x1 plus x2 x2 plus x3. What?
First option, please explain. First option.
First option. Okay. Okay. Let me see. B option. I'm going to first option again. Similar thing I'm doing in B. So I suppose it will answer your doubt. So now we applied first B and now we are going to apply U. So U of application of U. What U does? The numerator of all these are equal. So just we should worry about dividing by 2 or dividing by 3. That is all we should see. So first coordinate is z1 minus z2 plus z3. What here it will be x1 plus x2 minus x2 plus x3 plus x3 plus x1 divided by 2. This is your first coordinate. Second coordinate will be something which I'm not going to write here. I will edit this PDF and write it. You can check it after that. Let's see if what is this x1 plus x2 minus x2 minus x3 plus x3 plus x1 divided by 2. Now this x2 gets cancelled with this, x3 gets cancelled with this. Okay. So first coordinate is 2x1 by. So dividing by 2 is good. So we are getting in first coordinate x1, we'll get x2, x3. So this is the option is correct. Division by 3 is bad. Here it will become, if you are dividing by 3, the first coordinate will become 2x1 by 3, which is not equal to x1. So C fails. Since so okay, first option says line u. So we already applied t, so it is x1 plus x2, x2 plus x3, x3 plus x1. But it is adding first and second coordinate and dividing by 2. It is x1 plus x3 plus 2x2 by 2. First coordinate. Second, third, I'm not writing. What it is? X1 plus x3 by 2 plus x2. This is not equal to x1, right? We want x1 first coordinate. Then only u and t will be inverse of each other, because here we want identity of x1, x2, x3. We want first coordinate to be x1, second to be x2, third x3. Okay, so first coordinate of this is just ut of x1, x2, x3. Understood? If you, I suppose you understood. You are not telling anything.
Yes, sir. Yes, sir.
Understood.
Yes,
Okay.
sir. Yes, yes.
Forgot to switch on.
Okay. Okay. So let's see next question. Question 7. Let V be space of polynomial degree less than or equal to 2. What is dimension of V? Once you see the data, you should be clear this is equal to 2. 2, na? This is really 2? No, it is 3. Okay. This is silly mistake. You should be careful. Let me know if I'm doing wrong things. W is space of 3 tuples, all 3 tuples. So W, dimension of W is also, W is nothing but F3, which is 3. B1 is a basis. This is a basis. Okay. So this is not completely defined linear transformation. This is also basis. B2 is also basis. They are defining only on 2 elements. P is defined on 1 plus x square, 1 plus x. Another basis element is 1. They are defining this element goes to 0, 0, 1. Next element goes to 1, 1, 1. They are asking where to send P of 1. This is what they are asking. So that if we define where 1 goes, so that P becomes an isomorphism. Okay, in all the questions. So I showed something right now to you. If dimension of P, dimension of W, or finite or not equal. And dimension of V is equal to dimension of W. Then V from V to W is 1 1 if and only if and 2. This means is isomorphism. एक चीज शो कर दिया तो सब हो गए. Means if you have 1 1 which will be already because dimensions are equal and it will become isomorphism. So they are asking what T is isomorphism. So check one thing, either it is 1 1 or 1 2. So let's see what we can see. What is the rank of T? If rank of T is 3, we want rank of T. If it is 3, then what will be nullity of T? It will be 0 and nullity. Once nullity is means dimension of kernel T will is 0, then it will be 0 vector. Kernel T is this, and it will be implying T is 1 1. So once it is 1 1, it will imply T is isomorphism using that theorem here in this particular case because dimension of PV and W are same. Isomorphism. So we want rank T equal to 3. Then we are done. Okay. So we want all these 3 elements, whatever, let's say this is X. We want 0, 0, 1. They will span the whole image space 1, 1, 1. And this question mark. This set should be Li. We want Li means linearly independent. So what it should be? Something which makes this set linearly independent. Let's see options. T of 1 defining 1 1 2. Will this set be Li? Of course not. Why? A fails because 1 1 2 can be written as 0 0 1 plus 1 1 1. Means this third vector, which is question mark, is depending on first 2 vectors. Right? So it is not, it fails. Second, we cannot check directly. Third, this also fails. Why? Because 2 2 2 is depending on this 1 1 1, which is already there. Right? So C also fails. Now question is about B and C. Okay. Both might be correct because are correct. They are asking. And I'm saying both are correct. Okay. Because this vector does not depends on 0 0 1. Okay. Because 0 0 1 k multiples, all the multiples of 0 0 1, second coordinate can never be equal to 1. So it is not depending on first. Is it depending on second? No, because all the multiples of 1 1 1 will be of the form C C C, and this is not of that form. Is this depending on both? That is what means I'm asking. Is there C1 and C2 such that it is written like C1 into 0 0 1 plus C2 into 1 1 1? Means is this third vector lying on the plane spanned by 0 0 1 and 1 1 1? See, I want first coordinate to be 0. So C2 should be 0, right? Because this,
Yes, sir.
correct. So C2 is 0, then this vector went away. So we remain C1 into this. So this will become just C0, 0, C1. And this is not equal. So this is outside. Means 0, 1, 2 is not lying on the plane spanned by these two vectors. So it is linearly independent. So similarly, D is also correct option. Okay, same logic. Yep. So this third vector, which is T1, which is this vector, is not lying on this plane, which is spanned by these two vectors. So once it is outside, you add it, you will get again linearly independent set. This was base extension theorem. If you remember, we were adding vectors which are not already in the span, which are outside span. We are adding one by one. Now we are getting higher order, higher order set in linearly independent. Still, it remains independent. Okay. Mhm. This is all about question 7. Question 8. T and U be two linear operators on R4. Okay, T is given like this. It is linear operator, takes R4, elements of R4 and gets L, and again elements of R4. This is X also. These are all linear transformation because what the logic I said was powers are just one. 0 is an exception for that reason. Okay. Let the range space of Tu are equal to denotes by this. Null space of denoted by this. Then which of the following is correct? So hmm, someone want to say anything? If A is correct or not?
A is wrong, sir.
Someone said it is wrong. I
Yeah.
will verify everything. Okay. U T applied to x1, x2, x3, x4. First apply T, it will become x3, x4, 0, 0. U remains here. Now U, after application of U, what U does? U just takes first two coordinates and other two coordinates become 0. So it will become x3, x4 as it is. Another two coordinate is already 0, so it is 0. So it is not 0. Some non-zero vector is going to non-zero vector. So, and it says it is 0. So this option is incorrect. What is rank of TU? Okay. So we want number of free variables. Okay. What remains will be the rank. So apply TU on x1, x4. So it will become T of x1, x2, and then 0, 0. U is like that, right? Okay. So what T does, he takes third and fourth coordinate and makes them first and second coordinate. So it will become 0, 0, and all third and fourth coordinates are anyway 0. So, okay, this is incorrect option. Because T in Tu is equal to 0. So what will be the rank of 0 linear transformation?
0.
Correct. Mhm. So, okay. Now they are asking about intersection. Okay. Tu is 0. So RTU is just 0 vector. Tu is 0 linear transformation. So everything goes to 0. So what will be the rank? Sorry, range. Range space will be just 0
0.
vector.
0. 0.
So once you take intersection, with RTU. Again, it's subset of RTU, which it should be because it is subspace. Intersection of subspaces is subspace. For that reason, this intersection RTU intersection NTU, this is equal to RTU. Okay, because this is the smallest. 0 is the smallest subspace. What it can be extra. Since it is subspace of this, so it will become equal. So dimension of this thing is 0, but this also is incorrect. It should be 0. Okay. What about this? This should be correct option, but let's verify that. Okay. What is UT? UT, A option we already wrote here. UT is this range of E for UT is nothing but spanned by R E1 plus RE2, right? Only first and second coordinate remains. It x1, sorry, x3, x4 can be any real number, right? What it what is this range? This is the plane. If x, y, z, w are coordinates for R4, so this is xy plane, right? Means first two vector E1 and E2, they are spanning range. So any element can be written like this: x3 E1 plus x4 E2, xi belongs to. And what is NTU? Sorry, NUT, na? Okay, we want NUT. So what is going to 0? To calculate NUT, okay, let's see what it is. X1, x2, x3, x4, such that when you apply UT on this x1, x4, it becomes 0, 0, 0. So this is what? X3, x4, 0, 0. Condition, this condition here. X1, x4, such that this holds. This means x3 equal to x4 is equal to 0. x1, x2, x3, x4. So this set is equal to x1, x2, sorry, x1, x2, 0, 0, x1, x2 belongs to, and this is nothing but R E1 plus R E2, right? Here also you have first coordinate non-zero, second coordinate non-zero. It couldn't be anything. Means this is just xy plane or a four-dimensional space. Okay, x, y, z, w are bases. Then means they are coordinates. Then xy plane only. So what will be the intersection? Intersection will be both are same thing, right? Intersection is of two-dimensional. So this is correct. Everyone understood, right?
Sir, just show me the range space, sir. That n tuples. Yeah, okay, fine, sir, fine. Now I understand, sir. Thank you.
From part A, it follows range space of UT is just Question number 9. P be a linear operator.
Please enlarge, sir.
What?
Please enlarge the image.
ये दिख रहा है?
Yes, sir, it is visible.
Okay. P be a linear operator on R5. It is defined like this. It is linear operator. Okay. RT and NT denotes range space and null space. And which of the following statement is correct? Okay. So it seems to me that first option is correct, but let's see. RT is just this 0, 0, x3, x4, x5, xi belong to R, which is equal to R tilde jar, yes, R E3 plus R E4 plus R E5 is spanned by these three vectors. The LS of E3, E4, E5. Okay, so what is NT? Okay, RT square. But first, let's calculate RT square. We should apply T once more to this vector. Means x1, x2, x5 T of T square of this xi belong to R. Once you apply, then one T remains and it will become 0, 0, x3, x4, x5. Psi belongs to R. Now, once you apply T, then what it will become? What T does? T does first two coordinates makes 0 and all three coordinates remain same. So it is just 0, 0, x3, x4, x5. Correct? Xi belongs to R. So it shows that RT square is same as RT. So dimension of means both will be same. So rank will be same. So first option is correct, right? I suppose it is good. So RT is contained in NT. Is it really true? Let's see. Any vector in RT will is of the form B. I'm writing here 0, 0, something ABC here. Is this belongs to NT? Apply T on this. It should become 0 if it is in NT. But it is itself ABC. It is not 0. No, this is incorrect. This was any vector in R. This belongs to RT. Now apply T on it. It remains same. So which is not 0. If ABC is not 0, it is not 0. So RT is not containing NT. What about C option C? This is element of RT.
Yes,
If you apply
it is element of range space, so definitely it is not a.
no,
Okay.
definitely नहीं बोल सकते. But
Sorry.
these elements are not in NT.
Oh, yes.
You can
Yes, sir. Yes, you continue, sir.
so if it is not a subset, how it can be basis of NT? So it is incorrect. So first of all, it should be non-empty subset of NT, and it should be linearly independent, and it should be spanning NT. So even first condition fails. It is not even subset. So it fails. So what about D option? intersection of NT and RT is 0. It is correct. Let's see. What is NT? NT is tuples x1, x2, and let me write completely. x1, x2, x3, x4, x5, such that P of same thing is equal to 0, 0, 0 vector. So this set is same as x1, x5, such that 0, 0, x3, x4, x5 is 0, 0, 0. Okay. So this implies x3, x4, x5, all these are 0. x1, x2, x5 such that this holds. Now this set is equal to this tuple x1, x2, all three coordinates are 0 such that xi belongs to R. But this is nothing but span of E1 and E2. Okay. Now what is in intersection? x1, x2, x5 belongs to NT. This will imply x3, x4, x5 are 0, correct? Belongs to RT. This will imply x1, x2, these two are 0, right? The definition of RT, where it is. Something belongs to RT if first two coordinates are 0, right? Okay. So x1, x2 are 0. But if these both together happening, so every coordinate is 0. Xi is 0 for it. So last option is also correct. In the intersection, you have just 0 vector. Okay.
Sir, I have one doubt, sir. Suppose they are asking about the dimension of RT intersection NT, then what is the answer, sir?
Will be 0 because intersection is 0 subspace.
Okay, okay, sir.
Okay. Everyone else understood, right?
Yes, sir.
This is last question. We have half an hour. Let's see. E and D be two linear operators on this space V, which is set of all polynomials over R. EP is like this. Oh, do you see EP is integral of P? EP is this abstract integral of Px, right? And dP is derivative of मतलब dP by dx. See this, right? Mhm. Now they are asking which options are correct. Let's see first. I suppose this one you understood. They said integration of x or I is x for I plus 1 by I plus 1. All the coordinates pi is still same thing. So these two are thing to understand. D into E is equal to I. Question mark. Anyone wants to answer this? Q apply E, then D. This is correct option. Why? If you apply E first, so okay, let me write it. P n x for n. This polynomial goes to applying E. P naught x plus P1 x square by 2, right? Plus and so on. N, sorry, Pn x power n plus 1 by n plus 1, right? Is like that. Now you apply D. Then differentiation of x is 1. P naught, it remains just P naught. But it will be 2 comes ahead of P1 and this 2 gets cancelled. So it is just P1 of x. 2 minus 1 is just 1. Right? It is just Pn of x. So directly you can go by identity method. So T into E is identity. A is correct option. Everyone understood? Then say yes, maybe.
Yes.
Okay. Let's see about B option. What can you say about B? If it is correct or incorrect?
False, sir.
False. Okay. Let's see. Someone says false. Apply on constants.
Yeah.
Suppose so, it will become ED applying on, let's say, 1. We should get 1. If it is identity, we should get 1. What it is? D of 1 is 0. Now, but now integral of G is 0. This abstract integral is, you can apply this formula directly, which is definition of E. So it is 0. We are not getting 1, which is not equal to 1. So it is not equal to identity. This is incorrect. So we have 3 options. ED minus DE is equal to identity. Use part A and write I here in place of D. So what they are actually asking is C ED is equal to 2I, right? From A. Question mark is here. If ED is 2 into I. This is incorrect. Use B. Use B. So get contradiction. Right? This also is incorrect. किसी को डाउट है इसमें?
No doubt, sir.
No doubt. Good. Okay. Option D. Let's see what it is. They are saying DE minus AD is equal to I minus XC. So in place of DE, again you write I and cancel with this I. Using A, and then it will become minus of ED is equal to minus of XC. Yes, they are asking. Okay. Here I'm writing. Use A to reduce it to question mark is here. ED is equal to X into I. Question mark is here. Right? So apply on 1 again. Use B. Similar tick as B. ED on 1. We should get X into 1, right? Identity, if you apply identity map on 1, it is 1. So in question mark is here. but here it is 0, here it is x, which is degree 1 polynomial. It is uh, having minus infinity degree polynomial, which is of course not degree 1 polynomial, that is clear. So these are not equal. So ED is not equal to x into identity. Means I should write it x into y. Maybe. But if you understood, then it is good. So this is also incorrect option. Okay. $20 are left. If you have your doubts from your class, maybe some exercise in linear algebra, you can ask. Okay.
In assignment 1, I have a doubt, sir.
Okay. If you can tell your question, it would be good.
Yes, sir. But in the solution part, they have given only the answer. The solution is not derived, sir.
I don't understand, but you can ask your question. What it is?
Let P3 of x be the vector space of set of all polynomials of degree less than or equal to 3.
Okay.
W be the subspace of P3.
Okay.
Consisting of the elements P of x is equal to A naught x cube.
P naught
X
x
cube
cube
plus A1 x square.
plus A1 x
X
square
plus A2x
plus A2x
plus A3.
plus A3.
Then P of x can take the form
One minute. What was this first term?
A naught.
This is A naught. Okay. This selection.
Yeah.
Okay.
Then P of x can take the form.
E of x can take the form
The options are, first option is A naught greater than or equal to 0.
A naught greater than or equal to 0.
Second option is A2 is equal to IA1.
It is equal to I A1.
Third
What is
option is
I?
square root of minus 1.
Okay. Then field we are taking is complex size.
Yeah.
Okay. Okay. Next.
A3 is equal to
Mm.
A1 plus alpha square A2.
A1 plus.
Alpha square A2
Okay.
to R.
First
A3
of
is
all,
rational.
A3 belongs to Q.
No, sir. The alpha belongs to R.
Okay. Alpha belongs to R.
And the last option is A3 is rational.
A3 belongs to Q. 1 minute. I'm getting these two same. P3x and W. What is characterization of W? Can you tell me once more?
In the question, they have mentioned like this only, sir.
The two collections are same anyway. What
No,
is
sir.
subs?
Which of the following W is a subspace of P3? That is the question, sir.
Oh, okay. So
Hmm.
W in each case, we want to check P3 of X का subspace or not. If all AIs are greater than or equal to 0, sorry, A0 is greater than 0, sorry, greater than 1,
Greater than 0 only, sir.
greater than 0, it is of course not subspace. Why? Let's say here we have one element x cube only. Okay? What should be its inverse? मतलब W should be a abelian group first of all. Being a subspace is a vector space. Vector space means it should be under plus, it should be abelian group. So what is the inverse of this element? This will be minus x cube. But it is not in W. So W is not even a abelian group. So first option is incorrect, right? Okay. I suppose you understood this. Okay. Second option is saying A2 is equal to IA1. Yes, it is a subspace. What is characterization of W? This is A0 x cube plus A1 x square plus I A1 x plus, I'm writing here A3, but it could be any constant. AI belongs to C. This is subspace. You want to ask why? Just
But in
need to check.
in the question, they have mentioned that let P3 of x be the vector space of set of all polynomials of degree less than or equal to 3 over R, sir.
Over R.
Uh,
So it is incorrect.
Yeah.
If here it is R. So if you use this B condition, W is not even subset of P3 here. P3, let's say I'm mentioning in subscript R. W is not even subset of P3 R. Okay? Because here we have coefficients which is constant. So this is also incorrect. What about P? This third coordinate depends on first and second coordinate in this way. Alpha square is just a real number. You can take anyway some C, okay, some positive C, which is greater than or equal to 0. Alpha is a constant number, some alpha square is positive number. It can be 0 also. So once it is 0, what is description of W? Here everywhere it is R. Okay. So A0 x cube plus A1 x square plus A2 x plus in place of A3, it will become A1 if is equal to 0. Otherwise, A0 x cube, sorry, plus A1 x square plus A2 x plus, here it will become A1 plus C A2 if C is positive. In both cases, and all these AIs belongs to all the coefficient W is subspace of P3. Okay, you can check it.
Yes, sir.
I suppose you can check it. Okay, 1 minute. If here it was A2 square, maybe in this condition, A2 square, then it fails because power is linear in this constant term, which is dependency. A3 is depending on A1 and A2, but How? Linearly dependent. That is why it is subspace. Okay. So this is correct option. You can check it. If A3 is in Q, this is again incorrect option because W is not closed under scalar multiplication. Details since W is not closed under scalar multiplication. How? 1 belongs to W, right? A0, A1, A2, all these 0. In place of A3, I'm taking 1. So that element belongs to W. And A1 is 1 is rational also. But in scalars, what are scalars? Scalars are R. So under root 2 times this element, which is vector in W, it should belong to W. But this says ki A3 is equal to root 2. 0 x cube plus 0 x square plus 0x plus root 2. This does not belong to W. Because A3 here, it is not rational number, right? So D fails.
Sir, explain the first option once again, sir. A not equal to 0 is false. A not greater than or equal to 0.
So I'm saying take x cube, it belongs to W because coefficient is 1 and 1 is bigger than or equal to 0, right? What is inverse of x cube? Minus x cube does not belongs to W because so coefficients of x cube, which is A0, here it is minus 1.
Okay, sir.
Because of, so this implies W is not abelian group, not a vector subspace.
Understood, sir. Thank you.
Okay. Anyone else? If we have 10 more minutes.
Which one is correct, sir?
Option C. Yes. I'm leaving this verification. I can see it is a subspace. Here it is written. You can verify it. Okay.
In the first option, A0 should not be negative. That is the condition. Is it not?
Yes. In the first option, A0 should not be negative. It is not a subspace. It is not even a vector space.
Yeah, that's what given it is. A0 is greater than or equal to 0 means non-negative.
A0 is non-negative. Yes. So then W is not a vector space. You understood that part, right? Here, here I told x cube belongs to W, but minus x cube does not belong to W. So W is not even abelian group. Abelian group, for abelian group, every element should have inverse. So W is not W with respect to plus is not abelian. Or not a group. Okay, so into some question which I remember. Take this. Let's say P9 coefficients from R x. which is set of polynomials degree of degree less than or equal to 9. Thus that p of x is equal to p of minus x and p of uh, what is my age? Uh, let's say my birthday is in 2001. It is 0. With this condition, I'm taking set of all polynomials of degree less than or equal to 9. Let's say I'm denoting x I star. It's just a notation. What is dimension of this? Let's say this is v, dimension of v. So you can calculate it and tell me. 2 minutes. After 2 minutes, I will explain and time will be over.
Sir, is it a vector space? Is it forms a vector?
Yes,
Okay.
it is a vector space. Okay, set of all polynomials which vanishes, let's say at a 1, they form vector space. So this second condition says, matlab nothing to worry about. It is a vector space. First condition we already saw that px is equal to p minus x. After applying this condition, what happens? All odd degree terms disappears, right?
Yes, sir.
So now how many free coordinates are left in random polynomials of degree less than or equal to 9? Applying all these conditions, so we have a0 plus a1x plus a9 x power 9 evaluated at -1, we should get, sorry, minus x. Same thing at evaluated at plus x. This condition will imply a0 minus a1x plus a2x square minus a3 x cubed and so on, minus a9 x power 9. Right side it is same, a0 a1x plus and so on plus a9 x power 9. So
Dimension 5, sir.
dimension is 5.
Yeah.
Okay, let me verify it. So okay, what, why I'm cancelling -7? A not can get cancelled. Sorry, at that time I was wrong. Even degree terms get cancelled, right? Yeah. So what left is general polynomials of this V is of this form: a1 . Am I correct or not?
Only so given p of x is equal to p of minus x, so it is a even degree polynomial. So odd degree polynomial will get cancelled.
Making mistake here, right? A1x gets cancelled with A1x. Okay, all these two are equal. Okay, A naught gets cancelled with A naught. What is? Some wrong thing is happening. Okay, this is a
All
all.
terms will become twice, 2 times.
Then after that,
Equal to 0.
oh, okay. So, sorry, this condition will imply, right, 2 into A1x,
Plus a3 x cube
A3x cube,
plus
right,
a
right,
power 5 x power 5.
A9 x power 9. This will be equal to 0,
0.
and this will imply A2i plus 1, all odd degree terms. These coefficients are 0 because this is 0 polynomial. So what left is this A0 plus A2 x square plus A4 x4 A6 x6 A8 x4 8. Okay, how many free coordinates it has? 5. So someone said dimension is 5, but he was not thinking about this condition. So after applying this condition, one more we will be getting dimension is equal to 4. Okay, this is incorrect. Dimension of V is equal to 4. V is this collection. Thus that A0 plus B1 A2 plus B4 A8 is equal to 0. Right. C1, C2, C4 are some constant. Uh, some constant. Okay. They are 2000 square, 2000 or 4 like that. C1 is just 2001. So C4 is 2001 power 8. Okay, some constant. Ci is non-zero constant. So if you have 5-dimensional vector space and you get some linear condition on coordinates, one linear condition, it becomes a hyperplane on that. So initially you must be thinking like this is 5-dimensional, this is 5-dimensional. But after applying this condition, we can remove A naught because A naught depends on A2, A3, sorry, A2, A4, A6, A8. So in place of A naught, we can remove by this relation. So just 4 free variables. What 4 free variables? A2, A4, A6, A8. And A naught is depending on, uh, because of this relation, depending on others.
Understand,
So
sir.
we,
Understand.
okay, good. So this is almost time and I'm stopping. We will meet next week on Monday. So in the meantime, you know my email ID. You can ask your doubt if you wish. You can come with your doubts or we'll go like this. Okay.
Sir, your mail ID, sir?
In the last class I told, but let me send you in chat box.
Yes, sir.
And
Yeah, it's received, sir.
Thank you everyone
Yeah,
for
thank you.
listening me. Thank you.
Thank
Yeah.
you. Thank you, sir. Nice presentation, sir.
Okay. Thank you.
Thank you, sir.
Okay.
Bye bye.
Thank you. Thank you, sir.
Bye, sir.